All right, chapter 2, section 4, like terms. Another way to look at this is Halloween candy. So I'm going to put a little HC up here, guys. HC, Halloween candy. We have been doing this for so long that it should not be anything new for you. Halloween candy. Like terms, here we go. The different parts of an expression are called the terms of an expression. They are the parts separated by addition or subtraction. Numbers alone are called constants. So we have some definitions here for you to do. So I'm going to put the word, well, I'll abbreviate it, D, E, F. I'm sorry about my D there because, again, I'm doing this by a mouse and it's not always the easiest there. So let's look at the word terms here. They said the different parts of an expression are called the terms. Really, it's anything with that's not an operation. So if it's not a plus, if it's not a minus, if it's not a subtraction or division, it is a term. So when you look at negative 4xy, it's all together. So it's negative 4 times x times y. That is just one term. Now, when you look at two terms, let's take x squared minus 16. If you ignore the little minus here, you have one term here, and then you have a second term here. That is why it's two terms. You just completely ignore the operation in the middle. How do you get three terms? Same way. Negative 4y is 1. 6x is 2, or the second term, and xy is the third term. Again, you are completely ignoring the operation. So the plus and the minus that were there, ignore them. On your paper, your answer would be negative 4y, 6x, and xy separated by commas if they're just asking for the terms. So with that, let's go into example number 1. It just simply says, name the terms and constant in 4x minus 2x plus 7. And I'll get to the constant here in a second. The first thing we can do on paper is we can name our terms. So we know 4x is 1, we know 2x is 1, and we know 7 is 1. We are getting rid of the operations, okay? So on paper, you would want to write 4x, comma, I'm going to try to see if I can squeeze that in, 4x, comma, 2x, comma, oh, there we go. And finally, the last term was 7. That is all you have to do to name the terms. However, it said, hey, what about the constant? Let's go back up here in our definitions part. The parts separated by addition and subtraction, numbers alone are constants. So numbers alone, well, here 4x, 4 is not alone. 2x, 2 is not alone. But look at the 7. The 7 is all by itself. It is called the constant. So your answer for the constant part would be just 7. Okay? And I think they make that pretty easy on our work. They don't ask for two things in one answer. So they're not going to ask for the constant and the terms. They're just going to ask one or the other. One more thing that you need to look at right here. Here's the answers, okay? Just like I said, with this little x's, there are three terms, 4x, comma, minus 2x, and 7. And I forgot to carry my negative over there, but they are correct. If you look back up here in this subtraction is going with the 2x. It belongs to that. And this is going to be very hard for you to go, oh, well, that's an operation. That is correct, but in this case, it is a negative, and so that negative goes with it. I'll be very lenient to begin with. We'll just get tougher as we go. Coefficient, by the way, 7 is a constant. The coefficient is a number that multiplies a variable. So a coefficient is only a number before the variable. So in this case, 3 times x, or in 3x, 3 is the coefficient. That's it. That's all you have to say. Tell me, what is the coefficient of 3x? 3, because it's the only number before the variable. If we had to go up here into this one term, What is the coefficient? The coefficient would be -4. What is the coefficient x squared? We're going to get to that in a second. You don't see a number, but how many x's are there? Well, there are 1. So the coefficient would be 1. 16, by the way, is not a coefficient. That would be a constant because it is only a number by itself. If we were to look at our other example, -4y again, this case, -4 would be your coefficient. 6 would be a coefficient. And what's missing on the xy? How many do you have? 1x and 1y. So they don't have the number there, but the coefficient would be 1. And they explain this down here back to our coefficient section. A squared, notice they put a 1 in here. So how many a squareds are there? There are 1. So the coefficient of a squared is 1. If you had -y, again, what's the coefficient? It's 1. It goes right before the y. I'm not going to try to squeeze it in there, but anytime you just see a variable by itself, then you can assume the coefficient is 1. In example number 2, name the coefficients in 3x squared minus x plus 4. So we are only looking at numbers that come before variables, and they highlighted them in blue. 3 is a coefficient. Notice they didn't highlight anything else. Okay, it's just 3. And then notice the x here, but how many x's do you have? 1. So you're going to put 1, but that's going to become a negative because that's a subtraction. So if you were to change this to an addition problem and then make it negative, like we had been doing in previous lessons, that's where you're getting that negative. That's why it needs to stay with it. Now, notice they do not have the 4 highlighted because the question said name the coefficients. Well, we know 4 does not have a variable or a letter, and that means it's a constant. It did not ask for a constant, so 4 is not part of our solution. Last but not least, here, like terms. This is the Halloween candy. Like terms have the same variables with the same exponents. All numbers are like terms. We had our Halloween candy bag and we dumped it out and we sorted Milky Ways with Milky Ways, suckers with suckers, Tootsie Rolls with Tootsie Rolls. They're trying to tell you here 3xy is the same as -yx. Even though y and x are switched, it still has x and y in it. Okay, so that's still a Snicker bar and 3 Snicker bars. 4a and 3a below it, same thing. Let's say 4 suckers and 3 suckers. You can combine those. Those are like terms. -5x squared and 2x squared. Again, we're looking at the variable and the exponents. If they are the same, then you have the same product. So we have a Tootsie Roll, -5 Tootsie Roll, and a 2 Tootsie Roll. Here's where the unlike terms are. You cannot combine x and y. So different variables cannot be combined. You cannot combine z with A and AB. Well, this A is there and this A is here, but this A is attached to B, so therefore it is unlike. And finally, it gets the exponents. Here there are no exponents, it's just x. And on the other one, it's x squared. There are 2 for the exponent. That is unlike. And so for your example, in example number 3, are 3x squared y and yx squared like or unlike? Well, let's just go take a look at the variables first. So you have x squared and x squared. You have y and you have y. We don't care about the coefficients before them. They can be different digits, and that's okay. So in this one, yes, 3x squared y and yx squared are like terms because the variables are the same and the exponents, in this case for the variables, are the same. So in your bookwork today, you are simply ignoring the tan box on page 37 at the top, and you are not going to do 13 and 14. You do need to pay attention to the directions because they change 3 different times on this work. On numbers 1, 2, and 3, it said name the terms in each expression. So on paper, if this was my assignment, which it will be, numbers 1 through 12, I'm going to write today only answers. Okay? I do not need to write out the problem, just the answers. Name the terms in each expression. Well, we know I'm getting rid of the operation. So this is going to be gone. I'm going to kind of blot it out, and this is going to be gone. blot it out. What is left? I'm going to have 3n. I'm going to try to write as neatly as possible. Then I'm going to have a comma. So 3n is one term. 4p is another term. Make my p dangle a little bit. Sorry about that. And then another comma. And then finally 2. That is all I need for my answers. 1, 2, and 3, name the terms. In 4 through 9, they want the coefficients. And if you go back, coefficients are just the numbers that multiplies the variables. So again, it is only the number that's in front of a variable or letter. So in number 4, I only need to see your answer, which is, what is the coefficient of 3a? It's 3. Do not put a back down with it. A is the variable, and it didn't want a variable. It just wanted to know what the coefficient of 3a was, and the coefficient is the whole number before the variable, or the number before the variable. Pretty simple. 5, 6, 7, 8, 9. Do not write out the problems. Just tell me the coefficients. Be careful, and I'm going to give you one example right here. Let's do number 5 really quick. I'm not going to give you the answer, but one of your answers should be 1, because how many x's are there? 1x. No, you're not putting the x, you're just putting the 1. And then there are 2 other coefficients, or 1 other coefficient. All right, so be careful, they're trying to trick you. And then finally, 10, 11, and 12, you just have to tell me, are they like or unlike? And again, you're going to think Halloween candy. I'm going to put a little HC for you right there. Halloween candy, dump it out. And can you put them in the same pile because they're the same thing? All right, that's your work, doing numbers 1 through 12. Go.